Hello students, welcome to Educate. In the last class, we have discussed about the reactions in solutions. Now, in this class, we will discuss about the numerical questions based on the firstly about the reactions in the solutions and then after the other questions. So let's see. First one here. First question, what's the, read the question. So question here is, you have to dissolve NaOH in an amount of NaOH is 4 gram. So when 4 gram of NaOH will dissolve in water to form 250 milliliter of the solution. That means 4 gram of NaOH will have to dissolve in enough water to form 250 milliliter of what solution. Enough water means not, that means water it will be in too much quantity. That means here enough water means how much desired water will be there. Guys, I have told you here that when a solid dissolves in a liquid, there be no appreciable change in the volume of the solution. Okay, no appreciable change in the volume of the solution there is. So let's see here. So what you know, already you know that molarity is the number of moles of solute dissolves present in 1 liter of the solution. Molarity is the number of moles of solute present in 1 liter solution. That is, so here that is given 4 gram NaOH. So solute here is NaOH and solvent is water. So you will have to find out the number of moles of solute. That means NaOH is how much, and that has been dissolved in 250 milliliter of the solution. So in 250 milliliter solution, that much be the number of moles of NaOH dissolved. So when the volume of the solution will be 1 liter, then when the volume of the solution will be 1 liter, then how much number of moles of solute would be there. Okay, so let's see here. So that is NaOH, their weight is given how much? So NaOH, weight of NaOH given here 4 gram. So number of moles of NaOH will be 4 gram upon molecular weight of NaOH. Now find out molecular weight of NaOH. Sodium 23, oxygen 16 and 1 hydrogen. 40. So that is that upon 44 gram, that upon 40 gram per mole. So number of moles of NaOH will be 4 gram, that upon 40 gram per mole. So gram cancel out, mole inverse when will go in the numerator, that become mole, and 4 and here 10, so that will be 0.1 mole. Okay, so in that much 0.1 mole of, that means here guys, if you will solve the question by the concepts, then you could solve the numerical questions of the IIT main, NEET, CEET and any competitive examination. But if you will try to solve the questions by mugging the formula, then of the 11th class or the 12th class, you could do that. But you will face difficulty when you will consider about the NEET examination, the IIT main, advanced or CUET examination. For that, you will have to rely on the concepts. So here I shall discuss by the concept. By the concept, if you will solve, and if you are not making this IIT or the NEET examination as the target, even though you will feel very easy when you will prepare exclusively for the 11th class. So let's see here. Firstly, the number of moles of this one is that much, and that has been dissolved in 250 milliliter of the solution. So that means here in 250 milliliter of the solution, number of moles of NaOH is 0.1. So when in 1 liter means 1000 milliliter. 1 liter means 1000 milliliter. In 1000 milliliter, what will be the number of moles of NaOH will be? In 250 milliliter solution, when the volume is 250, when the volume of the solution is 250 milliliter, then the number of moles of NaOH is 0.1. So when the volume of the solution will be 1 liter, then what will be the number of moles of NaOH? That will be their molarity. Okay. So in 1 liter, number of moles of NaOH will be 0.4 mole. So therefore, molarity of solution, that will equal to 0.4 mole per liter. Okay guys, very easy this question was. Now proceed. This question. Here molarity is given and it is asking molarity of the solution. Okay guys, that means molarity is 3m. Molarity of the solution is 3 and density has been given. Density of the solution has been given. Okay, so that is asking what will be the molarity of solution. Watch out this question carefully. This question how to solve, watch out carefully. So let's see. Firstly, read the question by yourself. Firstly, watch out, carefully read the question. Now I hope you have read the question. Now let's see how to solve the question. Molarity of the solution is 3m. Means when volume of whole of the solution is 1 liter, then number of moles of NaCl is 3. Molarity is 3m means 3 mole of NaCl. 3 mole of NaCl will be present in 1 liter of the solution. So here when volume of whole of the solution is 1 liter, then the number of moles of NaCl is 3. In any way you tell that. So let's see here. So here assume in 1 liter, when the volume of the solution will be 1 liter, then what will be the mass of the solution? So you know density equal to mass upon volume. So density of solution will be equal to mass of solution upon volume of solution. 1 liter is the volume of whole of the solution. So when we will find out density, when we will put the density of solution as 1.2 gram per milliliter, then we will have to take here this one. So 1 liter means 1000 milliliter volume we can take. 1 liter means 1000 milliliter. So molarity is 1.25 gram. Okay, density is 1.25 gram per milliliter. So let's see what will be its mass. So density is equal to density is given here. Why I have taken 1000 milliliter? Because 1 liter is 1000 milliliter. 1 liter is 1000 milliliter. Density has been given here in gram per milliliter. So gram per milliliter here, that is given. So if we will take here volume in milliliter, then we will get the mass of the solution in total mass of the solution in gram. So that's here, very simple. So milliliter inverse and milliliter, that will cancel out. So that will become 1250, that much gram. Okay guys. Now to calculate the molality. Okay, again I am doing this one. I am making this question. Okay. Okay, firstly write that. Then after I shall tell you. Mass of solution will be 1250 gram. And molality, you know, molality, that is number of moles of solute that upon mass of only solvent. This is the mass of whole of the solution. 1250 gram is the mass of whole of the solution. And you will have to find out the mass of this solvent only. So how to calculate? Let's see. So there is this much. So there is 3 molar solution. Means number of moles of NaCl present in the solution is 3. So what will be the weight of NaOH in the solution? Firstly, watch out there. Since here unit has been changed, but substance has not changed. Just like that, to your mom, if you will tell mom or ma or mummy or ammi jaan or mama, then identity or the relationship will not change. So same here, the quantity not change, unit has been changed here. I have derived in different units. Okay. So let's see here. So in that means in when the density of that means when the volume of solution was 1 liter, then 3 mole of NaCl was present in that solution. And I am telling that 3 moles of NaCl is present in 1250 gram of water. Question 3 molar solution means here 3 mole of NaCl is present in 1 liter of the solution. And I have here calculated that 3 moles of NaCl is present in 3 mole of NaCl is present in 1250 gram of the solution. Okay, so doesn't mean here firstly it is in terms of volume. No, I have calculated in terms of mass. Let's see here. So mass of NaOH present in solution is how much? That is 3 into their molecular weight. Okay, so okay, again guys, I am telling why I am calculating here, because if I calculate the mass of NaCl, the mass of NaCl present in the solution, if I calculate the mass of NaCl present in the solution, then mass of solute and mass of solvent, that will be equal to 1250 gram. So if I calculate the mass of NaCl and that quantity I subtract from the mass of whole of the solution, then I shall get the mass of water, because the mass of solute plus mass of solvent, that will be equal to total mass of the solution. So let's see here, mass of NaCl, that will be equal to 3 into their molecular weight. And how to find out the molecular weight of NaCl? NaCl it is here 23 and 35.5. So that means 58.5. So 58.5 gram, 3 into 58.5, that much gram. And that will equal to how much? (175.5 gram). So mass of NaCl is 175.5 gram and mass of whole of the solution is 1250 gram. So if we subtract the 175 gram from 1250, then I shall get the mass of water. So what will be here? So mass of water will be how much? Calculate that here. So here 'this is mass of water is that much. Convert them into kg. So that will be equal to here, that's divided by 1000. So molality will be equal to To calculate the molality, you need the number of moles of solute and the volume of the number of moles of solute and the mass of the number of moles of solute and the mass of solvent in kg. So molality, that will be equal to this one. Number of moles remains same. Number of moles remains same, 3 mole. 3 mole or 175.5 gram of water is there. Like that, if suppose imagine that if the weight of one banana is 100 gram and you have purchased 6 banana. So if you tell that I have purchased 6 banana, or if you tell that I have purchased 600 gram banana, then will the quantity of the banana change? Not change. Same here, 3 mole of NaCl is present in 1 liter of solution, and here I am telling here is 175.5 gram of NaCl is present in 1 liter of solution or in 1250 gram of solution. The same term it is here. So that will be equal to here 3 upon so that will become nearly about 2.8, that much mole per kg. So molality of the solution will be nearly about 2.8 mole per kg. Okay guys, clear? Now let's see. This question here, 1.1, very easy here. Mass of the following here, what's that? 2, hydrogen is 2 and atomic weight of hydrogen 1 plus 16, so 18. So molar mass of water is 18 here. This one we have calculated. Here mass percent of different elements you will find out in sodium sulfate, Na2SO4. So let's see here, Na2SO4. Firstly, find out the molecular weight of Na2SO4. That will be how much? There is 2 sodium. So 2 atomic weight of sodium is 23. So that's why 23. Sulfur atomic weight is 32. So 32. Here there is 4 oxygen. So 4 into atomic weight of oxygen is 16. So that's why 16. So that is equal to 142 here, 142 U. Guys, here simply I have calculated the molecular weight of Na2SO4. So 2 here, sodium atomic number here there is 2 sodium in this molecule. So that's why 2 into atomic weight of sodium is 23. So that's why into 23 plus atomic weight of sulfur is 32. So that is, and there is 4 oxygen and the atomic weight of oxygen is 16. That's why 16. So 23, 2 into 23, 46 plus 32 and 4, 16 into 4, 64. So that will be after calculation that became 142 U. Now firstly find out mass percentage of sodium. So there is how much sodium? 2 into 23, this one 46. So that will equal to 46 upon total mass of the solution of the compound is 142. So 46 U that upon 142 U into 100. Calculate this one. 46 U upon 142 U. So that U cancel out. So now find out. That we're going to do. So mass percent of sodium is 32.39%. Okay guys, easy it is. Now in the same way you can calculate the mass percentage of sulfur. So let's see here. Sulfur here is, total weight of sulfur is here how much? 32. So that will be equal to 32. That upon molecular weight of this NO2SO4 is 142. So 32U upon 142U into 100. U cancel out. Now 32, divide 32 by 142. So 22.54%, that will be mass percentage of sulfur will be 22.54%. That one. Oxygen, as we have calculated the mass percentage of sodium and sulfur. So oxygen you can find out by also without calculating. So it will be here 32.39, 32.39 plus here is 22.54. 54.93, that's addition is came 54.93. So from 100 that subtract 54.93. So 46.04. So mass percentage of oxygen will be here, mass percentage of oxygen will be 46.07. This one calculated. Or you may calculate by this one also. Here by this, as you have calculated like that, same result you will get. Oxygen here 4 into 16, that much U upon here is how much molecular weight 142U. Same value you will get. Okay, guys? Question is here. This one. Now let's see about the next question. You will have to predict the empirical formula of oxide in which there is 69.9%, 69.9% iron and 30.1% oxygen here, dioxygen. So let's see here. So iron 69.9%. Iron is here 69.9% and oxygen is here how much? 30.1%. Okay. So firstly, how to calculate? First of all, that means you will have to find out empirical formula. So empirical formula tells that the number of, that means different elements are present in which ratio according to their, the different elements present in which ratio according to their number of moles. So firstly, find out the number of moles of iron. So number of moles of iron will be, that means here assume that there is 100 gram of sample. So in that case, there will be 100 gram of Fe2, but that means that oxides of iron. The weight of the oxides of iron assumed to be 100. So iron will be how much? 69.9 gram and oxygen will be 30.1 gram. If the weight of the oxides of iron will be 100 gram, then the weight of iron will be 69.9 gram and that of oxygen will be 30.1 gram. So firstly, and how to find out their number of moles here, ratio of the number of moles, that is empirical formula. So iron is here, weight is 69.9 gram. So number of moles will be how much? 69.9 gram, that upon that much gram, that upon molecular weight of, that means molar mass of iron, that is 56 gram per mole. That is here. In the same way, number of moles of oxygen, you can find out here, not O2, here oxygen atom, number of moles of oxygen atom we are taking. So that will equal to how much? That is 30.1, that upon oxygen is 16, 30.1 gram, that upon 16 gram per mole. Guys, any difficulty here? I hope this one is clear for you. So then after divide, here find out the number of moles of both iron and that of oxygen. So gram cancel out. Mole inverse, here gram cancel out, and mole inverse, which is in the denominator. Mole inverse is in denominator. So when that will go in the numerator, that will become mole. In the same way, divide 30.1 by the 60. So that will become 1.88. 30.1 divide by here 16. So that will become 1.88 or 1.89. So among this one, here 1.25 is smaller than that of 1.89. So take value. So ratio. So here by this one 1.25. So 1.25 divided by 1.25, that will be 1. And here 1.89 divided by 1.25. So 1.89 divided by 1.25. Oh, sorry. Yes. 1.89 divided by 1.25. That become 1.5. So that is here 1.5. Okay, simply. You will have to make them in a whole number ratio, whole number. So if you multiply by this one, that become 2. Oh, so that become 3. So multiply by whole to both of them. So that will equal to here, multiply this one, numerator. That means 1 by 1.5. So here also multiply by 2. Here also multiply by 2. So that become 2 by 3. So that become 2 is to 3. So that means in the compound, the ratio of iron and of the oxygen is 2 is to 3. So that's why empirical formula will be 2 iron and 3 oxygen. So that's why the empirical formula will be Fe2O3. Okay guys, clear? Not difficult? Now proceed this one. Read this question. So very simple here, you have to find out how much carbon dioxide will form when 1 mole of carbon is burnt in air. So 1 mole carbon here, that burnt in air is oxygen, CO2. So obviously 1 mole carbon gives 1 mole CO2. This equation is already balanced. If reaction will be not balanced, then you will have to balance the equation. So this is the equation for the combustion of carbon. When it and during the combustion of carbon, the carbon react with oxygen to form CO2. So obviously from this equation, 1 mole of carbon gives 1 mole of CO2 or CO2. And if you will have to find out atomic weight, its weight, so that will be 12 plus this one 32, 44. So if it will ask about in terms of weight, so 1 mole of carbon will give 44 gram of CO2, or in other word, 1 mole of carbon will produce 1 mole of CO2. Now second one, 1 mole carbon burnt in 16 gram of dioxygen. So let's see here, 1 mole carbon here that reacts with oxygen and form CO2. Already the equation is balanced. Here the same equation here. So I firstly write this one. I shall solve on that one only. I hope you have written. Now let's see how to solve this question. Oh, equation rubbed. Well, again, carbon reacts with oxygen, here CO2. Its weight is given 16 gram. Okay, so let's see here. 1 mole carbon here is 1 mole. Its number of moles will be how much? 1 mole carbon reacts with how much? 1 mole carbon reacts with how much oxygen? 1 oxygen 16 gram, 2 oxygen reacts, so 32 gram. So 1 mole carbon reacts with 32 gram oxygen. Here 1 mole, the number of moles of carbon available is 1 mole and the number of moles of oxygen required is 16 gram only. 1 mole carbon reacts with 32 gram oxygen. So here, but 32 gram of oxygen is not available in the reactions. So oxygen will be the limiting reagent. During this reaction, here 1 mole of carbon reacts with 32 gram of oxygen, but the amount of carbon available is 1 mole and that of oxygen is 16 gram. So that's why, since 32 gram of oxygen is not available, that's why oxygen will be the limiting reagent. And how much CO2 will produce, that will depend on the amount of oxygen. Now let's see how much here during the reaction here. So what is here? 32 gram of oxygen produces 44 gram CO2. So 16 gram of CO2 will produce how much CO2? So that means here 44 gram or 1 mole. So here 32 gram of oxygen produces 1 mole CO2 or the 44 gram CO2. So 16 gram will produce how much? So 1 gram will produce how much? So 44 upon 32, that much, or 1 by, or half mole that will produce. So no need to write that here. Or you may write here 1 upon 32, whatever be that. In terms of mole, that means in terms of weight here this much, or in terms of mole 1 upon 32. It is mole, it is gram. So here 16 gram, so 16 will produce how much? That much gram, or in terms of mole 1 upon 32, here this one mole and here 16. Here above 1 mole, below 1 is in gram. So that is 1 mole upon 32 gram. Here 1 mole upon 32 gram. So here is, or 1 mole upon 32 gram into 16 gram. So guys, here gram cancel out. 16 upon 2, 32. So that means 0.5 mole or half mole of CO2 will produce. Here weight of this CO2 how much produce? 16 to the 32. 2 and here 22. So 22 gram of CO2 or half mole of CO2 will produce when 1 mole of carbon burn in 16 gram of dioxygen. Okay guys, now same here, but nature of the question. Here for the third, the nature of the question has been changed. The nature of the question has been changed and same reaction there is. So let's see about how to solve this equation, this question. Okay, first of all write it. Now let's see. Same here, carbon reacts with oxygen and there is formation of CO2. Here number of moles carbon available is 2 mole and oxygen available is 16 gram. So amount of CO2 has been given in terms of the number of moles, while the amount of O2 has been given in terms of its weight. So let's see here. So what is here? According to the question, 1 mole carbon reacts with how much oxygen? 32 gram oxygen. So 1 gram carbon reacts with 32 gram of oxygen. Guys, same here. Here also oxygen will be the limiting reagent. When 1 mole have not reacted completely, then how the 2 mole will react? Okay. So, but let's see here. You can do that also. 1 gram carbon reacts with 32 gram oxygen. So here is, 1 mole, not 1 gram, 1 mole carbon. So 2 mole carbon reacts with how much? 32 into 2. That much gram carbon, 64 gram carbon. 64 gram oxygen. Okay. So here 2 gram carbon, here 2 mole carbon will react with 64 gram of oxygen. But that oxygen is not available. That means 64 gram of oxygen is not available for the reaction. So what will you here? Oxygen will be the limiting reagent. Now, how much CO2 will form? That will depend on the amount of oxygen. So, as in the previous case, in the same way this will form. So, let's see here. 32 gram oxygen produces how much? 32 gram oxygen produces 4 gram CO2. Here is 16 gram oxygen, so that will produce 44 upon 32 into 16. That is 22 gram CO2. Okay, guys, very easy question it is. So here, from the here question number 1.5, we have discussed here till 1.4. From here, onwards, after that, from 1.5, we will discuss in the next class. From here, then after, here is, then after we will discuss in the next class here. These questions, guys, keep in the mind, these questions, these three questions are too much important for those guys who are preparing for IIT main examination as well as for the NEET examination. These three questions are too much important. And in the next class, we will discuss about these questions here. This is otherwise the video will be longer. So this that means these questions about that. Firstly, we will discuss this question. Then after other one also. Okay. So it's all for this class. Thank you. Team Educate.